Long period variables, or LPVs for short, are cool, luminous, variable dying stars, such as giants and supergiants, that pulsate cyclically with periods that are typically longer than other variables. Let's take a look at where long period variables would fit on an HR diagram. Here we have an HR diagram on the left. We have absolute magnitude increasing in the vertical axis, and we have spectral class in the horizontal axis. Spectral class is based on surface temperature, where surface temperature increases to the left. Therefore, O spectral class is hotter than T spectral class. On this diagram, we see a diagonal line that runs from upper left to lower right, which is known as the main sequence. I will label this as M sub S. This main sequence is a region that has adult stars, stars that are not changing in size. They're not getting bigger and they're not getting smaller over a short period of time. Objects that are above the main sequence or below the main sequence are either growing up from birth or they're dying. There is a region to the upper right in this rectangle that's above the main sequence known as the instability strip. Inside this instability strip is where we find many variable stars. Variable stars cyclically pulsate, and that's where the variable part comes in of the name. Long period variables have typically longer periods in their pulsations than others inside the box, such as classical Cepheids or type 2 Cepheids or RR Lyras. One example of a long period variable is Mira. Mira has a very long period compared to those in the instability strip. Miras are found to the right. These LPVs are cooler. They're more on the right side of the diagram compared to the instability strip. They're luminous. They're as bright or brighter than some of the objects in the instability strip. And like the objects in the instability strip, they're variable dying stars. Stars that are in this circle region of LPVs are dying stars, just like the ones in the instability strip. These objects could be giants or supergiants, for example. On the bottom right, we have an animation of a Mira type long period variable. It gets bigger, and as it gets bigger, it gets cooler, and as it gets smaller, it gets hotter, and it should get a little bluer. Doesn't mean it gets blue, but it's going to change its color to a more deeper color towards the blue side. So maybe it turns orange. This artist chose to keep the color as red throughout this pulsation. But it gives you an idea of the pulsation in a long period variable.